Today, for my informative essay, I will be talking about welding and how it works. Welding is a process that joins materials together, primarily metals. It is a crucial technique in various industries, including construction, automotive, and manufacturing. This essay explores how welding works, focusing on its processes, tools, historical background, influential figures, and future trends. Understanding welding provides insight into its vital craft and its significant impact on technology and society. Welding involves heating materials to their melting point and sometimes adding a filler metal to create a strong joint and combine the metals. Several methods can achieve this. Arc welding, MIG welding, TIG welding, and spot welding are among the most common techniques. Arc welding uses a power supply to create an electric arc between the electrode and base metal. This arc generates intense heat that melts the metal, forming a pool that eventually cools to form a solid bond. An important variation is stick welding, where a consumable electrode coated in flux is used. As the electrode melts, it adds filler material, while the flux prevents contamination from the air. MIG welding, or metal inert gas welding, employs a continuous solid wire electrode fed through a welding gun. In this process, an inert gas like argon or helium protects the weld from oxidation. This method is popular in fabricating thin materials due to its speed and ease of use. TIG welding, or tungsten inert gas welding, differs by utilizing a non-consumable tungsten electrode. This method offers greater control and versatility, making it perfect for precise applications such as aerospace and automotive industries. Spot welding is another practical method primarily used in the automotive sector. It involves aligning two metal pieces and applying a small concentrated electrical current. This process melts a localized area of the metals, which then cools to create a bond. Spot welding is commonly used for assembling car bodies and other sheet metal structures due to its efficiency and speed. Welding technology has significantly evolved over time. Its roots can be traced back to ancient civilizations. The Egyptians and Greeks used rudimentary techniques, but modern welding began to take shape in the 19th century with the advent of the electric arc. Pioneers such as Nikolai Bernardos and Lincoln Electric's founder John C. Lincoln were instrumental in developing the first commercially viable electric arc welding systems. The impact of welding on society cannot be overstated. It enabled the construction of towering skyscrapers, bridges, and ships, transforming urban landscapes into the automotive industry. Welding is crucial for fabricating vehicles, frames, and parts, contributing to mass production efficiency. Welding has also been fundamental in the energy sector, particularly when constructing and maintaining pipelines and nuclear power plants. It is also very important in mining and build-up work, in the repair work in the mining around West Virginia and places like this. Several influential figures have contributed to our understanding of welding technology. For instance, Francis C. Smith introduced the concept of using gas to weld metals in the early 1900s. Advancements from engineers like Edward O. Lawrence further refined welding techniques, establishing standards that increased safety and efficiency. The development of laser welding marks a significant breakthrough in recent years. This process uses focused laser beams as the heat source and allows for precise and efficient joining of metals. Its applications extend to delicate electronics and thin materials, revolutionizing how complex assemblies are created. Innovations such as 3D printing show potential in the future of welding, where additive manufacturing techniques may allow for more efficient and versatile production methods. As industries adapt to new technological advancements, the role of automation in welding becomes increasingly prominent. Robotic welding systems are gaining traction, providing consistent quality and reducing labor costs. These systems can work continuously, ensuring high productivity rates and minimizing human error. Safety remains a vital concern in welding. Welders face potential hazards such as exposure to metal fumes, electric shock, and burns. Hence, the incorporation of safety training and protocols is crucial in minimizing risks. Organizations emphasize the importance of personal protective equipment, or PPE for short, such as helmets, gloves, and specialized clothing, which help shield workers from harmful elements. Looking ahead, the future of welding may be shaped by the development of smart technologies. Integration with artificial intelligence could enable real-time monitoring and adjustments during the welding process, enhancing quality control and efficiency. Virtual reality could also find its way into training programs, allowing aspiring welders to practice their skills in a simulated environment. In conclusion, welding is a multifaceted process with deep historical roots and significant contemporary relevance. Its diverse techniques allow for efficient joining of materials across various industries. Important figures in welding history have laid the groundwork for modern innovations which continue to have transformative impacts on construction, manufacturing, and safety. As technology continues to evolve, the future of welding looks promising, with emerging methods and automated systems paving the way for enhanced productivity and precision. Understanding welding allows us to appreciate this critical craft and its profound influence on our daily lives and the future of industrial manufacturing.